Hi there, and welcome to metauni. We're a community of scholars in the metaverse, and this is where we meet. We have seminars and classes and get up to some general nonsense. Over here, you can see some portals that will take you into pocket universes. Over there is the avatar editor if you want to try on a new outfit. And here are some metaboards. I'm going to write on them in a minute. One of the tools we use for attending lectures or classes on these boards are the orbs. You can see an orb in front of you. Please walk up to it and attach as listener. Once you've done so, you'll see at the top of your screen an item Orb Cam. If you click on that, you'll get a new and convenient view of the metaboards, as we call them. So while I have your attention, let me tell you something interesting. So we like geometry here at metauni. And that means we like Euclid. And Euclid says that given any 2 points, A and B, there exists a line between them. That's postulate 1. Postulate 3 says that given any point and a radius, there is a circle with that center and that radius. Here by line, I mean finite line segment. And you might say, what is this? Is this type theory? I thought this was geometry. Well, where do you think type theory came from? So given those postulates, we can prove proposition 1 of book 1 of Euclid's Elements. It says the following: to construct on any line an equilateral triangle. Proof. Proof is a diagram. Suppose given the line, call this point A, this point B. Postulate 3 says that I can draw a circle with center A and radius given by AB. Here goes. Postulate 3 applied to the point B and the line AB allows me to construct a second circle. Those circles meet, right? Well, which postulate tells me that they meet? Yeah, you should ask Dave Hilbert about that one. I'm not saying any more about it now. They meet at C. Postulate 1 says I can draw a straight line from C to A and from C to B. The definition of a circle, according to Euclid, gives us that the line CA has the same length as the line BA because they're common radii of the same circle. So AC equals AB. And for the same reason, BC equals BA. Common notion 1 of Euclid says that if you have two equalities like this, all three things involved are equal, right? BC is equal to BA and therefore equal to BC. So we have our equilateral triangle and we're finished. So welcome to MetaUni. Have fun, have a look around, and see you in one of our events.